Alright, we're back here in the second part of section 3.2, and we're going to talk today about the least squares regression line. And there are many different lines we could use to model the association. A good regression line makes the residuals as small as possible. And the regression line we prefer is the one that minimizes the sum of the squared residuals, So that's kind of what we have. So if we were to, in this case, look at those residuals and we were to square them and add them up, this is what we get. And we want the line that would keep that the smallest. Okay, so the least squares regression line is the line that makes the sum of the squared residuals as small as possible. All right, now how do we know if a linear model is appropriate? And we can use residual plots. Now, again, a regression line describes the overall pattern of a linear relationship and between an explanatory variable and a response. Now we see departures from this pattern by looking at a residual plot. And what the residual plot is, it's a scatter plot that displays the residuals on the vertical axis, and the explanatory variable stays again on that horizontal axis as we go here. All right, so again, here it is. Here's the original scatter plot that we have here. Now, if we were to go with those residuals, you can see this spot right here, not very big. This one is below. You can kind of see how those dots transform into this, where if this was right on the line, we'd see this right here. But again, you can see those residuals here. Once again, the explanatory variable stays on that horizontal axis, but instead now we're putting the residuals here, is residual plot. All right, now the residual plot magnifies those deviations and makes it easier to see unusual observation patterns. Now, if a regression model is appropriate, you'll see no obvious patterns, and the residual should be relatively small in size. Relatively is what we would say. Now, here's a couple of plots that we see here, and you know, when you look at these, it should show no obvious patterns. I think we see some obvious patterns, right? There's a pattern in there. On both of these, this looks like a quadratic pattern, and this one's tending to look like that too. And so a linear model is really not appropriate in that case. So we'd have to look for other options. So again, to determine whether a regression model is appropriate, look at the residual plot. If there's no leftover, if there's no curve pattern, then yeah, it is. Now, if there is a leftover curve pattern, like we saw there, consider using maybe a regression model with a different form. Use something different than that. So let's talk about our residual plots once again here. So going back to our forward example where we had the predictor for the price based on the miles driven, we might say, well, you know, here's the residual plot. Would we say that it's a linear model is appropriate? Well, yeah, there's no obvious pattern. And you know, relatively speaking, they seem pretty good. So I would definitely say it's appropriate as we go there. Okay, so that's going to be it for just the second part of 3.2. We'll kind of let that sink in, and then we'll move on to the next part next time. And so until next time.